Good morning. This lesson is for my Integrated 1 class. This is Unit 4, Lesson 2. Before I get started, I want to say that I hope everyone is doing okay out there. And let's just go ahead and jump into our goals. Our first goal is going to be reviewing writing equations in simplified form. Our second goal is to see how to write these equations when a fraction doesn't reduce. And our third goal is going to be how to graph these. So I'm just going to go ahead and jump right in. So I want to write the equation of the line passing through these 2 points. I have my formula here that I'm going to use. I'm going to simplify my formula, and that'll complete goal 1. So I'm going to fill out my table. All right, and to go from 1 to 4, I need to go by adding 3. And to go from 1 to 2, I need to go by adding 1. All right, and so now I can plug into my formula. F of x equals my first y value, which is 1, plus my change in y, which is 3, divided by my change in x, which is 1. So this is 3 over 1. And now I have my parentheses. This is always x, and I'm going to use opposite my first x value. My first x value is 1, so I need to use minus 1. And again, notice this fraction is going to reduce. The second goal is how to deal with this when it doesn't reduce. Okay, so I can rewrite this as 1 plus 3, because 1 goes into 3 times, x minus 1. All right, and so now I'm going to distribute. And I get 1 plus 3x, because it's 3 times x, and then 3 times minus 1 is minus 3. You learn how to multiply here. Now I combine my like terms, and I get f of x equals 3x. I have $1, I owe 3, that means I owe $2, and that's my equation. And remember, this is where this is my y value when x equals 0. I also want to point something out. This is going to be helpful for the next goal. Remember, we had the 6 steps to solve. Eliminate fractions, distribute, combine like terms, get all variables to one side, add or subtract away, divide away a number. Excuse me. So far we haven't done step 1, we haven't done step 2 or 4, 5 or 6. So we've been distributing and combining like terms. The next example that we're going to do is we're going to add step 1 and we're going to add step 6. And that'll be how we write equations when the fraction doesn't reduce. So I'm going to stop this part right here, erase this, and set up the next problem. I'll be right back. I'm back. All right, so we're going to go move on to our second goal. And remember, our second goal is how to write these equations when a fraction doesn't reduce. And so I thought it would be a good idea to just review how to eliminate a fraction here. All right, so what we're going to do when we eliminate a fraction is we're going to multiply everybody by the denominator. And what that's going to allow me to do is write an equivalent value of this. And I'm sorry I'm blocking this when I'm writing. I'm just having a hard time right now with my neck. I do apologize. I can't put my arm out as far as I like, but as you can see, I'm writing a 5 next to every number. So 5 times 2x is going to give me 10x. This 5 will cancel that 5, and I'm only left with the numerator. And that's equal to 4 times 5, which is 20. So that's what we're going to essentially, that's one of the steps that we're going to be adding when we write an equation when a fraction doesn't reduce. We're just going to have to do something we already know how to do. That's the nice part about mathematics, is we start combining steps we know. I also want to talk about how to rewrite a value. And I'm going to talk about the value 8, because this is something that I find students get stuck with in this problem, is they see a part of the equation and they think that they have 3 numbers. But in fact, we only have 1 number. So I'm going to say 8 is the same as 2 times 4. And I'm going to put a parentheses around the 4. Right? Because this is still the value 8. Now, I'm going to rewrite the 4 as the following. This is still technically the value 8. Because if I was to distribute, what we would see here is I get 6 plus 2, and that's equal to 8. So these are all equivalent ways to write the value 8. And so I like to go ahead and jump into this problem using this formula. But again, I want to point out, and I'll add this when I see it where I have space, is we're going to use steps 1, steps 2, steps 3, and step 6. 1 is eliminating fractions, step 2 is distributing, step 3 is combining like terms, and step 6 is dividing. Oh, okay, here we go. I'm sorry, I have a little problem with my neck. Okay, so I want to write this as a table, and I have 2 and 4, and 4 and 7. To go from 4 to 7, I need to add 3, and to go from 2 to 4, I need to add 2. And so now we can plug this into our formula, right? We get f of x equals my first y value, which is 4, plus my change in y, which is 3, divided by my change in x, which is 2, parentheses, x plus the opposite of positive 2, so it'll be x minus 2. I want to make sure that I'm in the camera here so we can see everything in there, and I do believe that's good. All right, that looks good to me. So again, remember we're going to do step 1, which is eliminate fractions. Step 2, distribute. Step 3, combine like terms. And 4, 5, 6, divide. All right. So this is my fraction 2, and you see that I multiply everyone by the denominator. That's why I did that little review right here. And so what I'm going to do is I'm going to multiply everybody by 2. But I want to point out that this is considered one number, just like this was considered one number, or one value. So this only gets 1, 2. All right, that's all I get to multiply this by. So this gets a 2, this gets a 2, and this gets a 2. And this only gets 1 because this is one value, just like I showed you right here. All right, so let's see here. So now this becomes 2f of x equals 8. These 2's cancel, plus 3 now, times x minus 2. I eliminated my fractions. Now I'm going to distribute. And I get 8 plus 3x. 3 times negative 2, that's minus 6. I'm going to combine my like terms. And I get 2. That's a terrible 2. I get 2 f of x equals 3x. 8 minus 6, that's 2. So plus 2. I combine like terms, and now I'm going to divide. I'm going to divide away the number with the f of x. So I'm going to divide everybody by 2. So I did that one, so I'm dividing everyone by 2. And now we get f of x equals 3 over 2x. 2 divides 2, and that gives me 1. This is a value of y when x equals 0. And so I hope, again, that this is not that difficult to do, and it makes sense. We're combining some old ideas here. This is from our first unit. And we're adding a couple things, but I wanted to, hopefully this is a simple process for you. So I'm going to erase this, come back and talk about the third goal real quick. All right, guys? So I'll be back. All right, I'm back, and I'm going to talk about the third goal here, and that's how to graph these. So I want to graph the lines that we created, but before I get started, I just want to review something really quick. We can graph ordered pairs. And I'm just going to assume, and I shouldn't do this, but I'm going to assume that I made the correct equation, this equation represents this. And if I look at it, it actually does. I plug in a 2, those cancel, and 3 plus 1 is 4. If I plug in a 4, the 2 turns that 4 into a 2. 3 times 2 is 6. 6 plus 1 is 7. So they do, in fact, work. So I'm going to graph these ordered pairs, right? So I go over 2. 1, 2, and I go up to 4. 1, 2, 3, 4. That's that ordered pair. This one, I go over 4 on my x, and they're called ordered pairs because they order the alphabet, right? X, Y. And this is my x-axis, this is my y-axis. So this one's telling me to go over 4, then up 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. All right, and I want to find the value of f of x when x equals 0. So I'm going to plug in x, or 0 for my x's on this equation, and I get f of 0 equals 3 over 2 times 0 plus 1. Well, guess what? Any number times 0, that goes away. So I can cross that out, and I get, when I plug in 0, or f of 0, that's equal to 1, which is an ordered pair. My x was 0, my y is 1. And I'm going to put that right there. And if you notice, these 3 points, they are linear. They make a line. And so what I can do is I can actually connect these. I didn't hit that one very well. I can connect these and make a line, and I want to point something out. And what I want to point out is this value of 1 is the value of 1 on the y-axis. So we're going to call this our y-intercept. Okay? And then this is our slope. This is how we move. Let me explain what that means. To go from this point to this point, I have to use slope. Let me explain what slope is. It's rise over run. And since I have a positive over positives, I'm going to rise up 3 and over 2. So if I go from this point, 1, 2, 3, and then over 1, 2, I land on one of the points that I used to make my equation. And if I go again up 3, 1, 2, 3, over 2, I land again on my other point. And so when the equation is written in simplified form, it's in a very simple form to graph. And I'm going to talk about how we graph. This is really quite simple. All right? So again, this is my y-intercept, this is my slope. And slope has 4 rules. Positive over positive, I rise up, I run to the right. Positive over negative, I rise up, run to the left. Negative over positive, I rise down, and I run to the right. I gotta learn the difference here. And a negative over a negative, I rise down and I run to the left. And I have the following little explanation. Graphing lines in slope-intercept form, f of x equals mx plus b, or y equals mx plus b. M is how we move to the next point using the slope rules, and b is where we begin on the y-axis. Now I do want to add one more thing that I think will be very helpful. If we have a negative in front of a fraction, put the negative up top. Just get in that habit of doing that. Now, if that doesn't work, you could also put the negative down below. All right, but it can't go to both. All right, so let me erase this and just make a quick example. I'm having a really hard time today, guys. Alright, minus 3 over 4x. You can do this. Okay. So I want to graph this. Let me make a graph real quick. I should probably make these lines closer together. Alright. So again, this is really easy to do. Okay, so what I'm saying, I have this in slope-intercept form, y equals mx plus b. This is where I begin on the y-axis. I begin at 6. So what I'm going to do is I'm going to put a point at 6. So 1, 2, 3, 4, 5, 6. Okay, b equals 6. Where I begin is 6. And m is negative 3 over 4. I have this. I'm going to put the negative up top. So this is telling me I have this, a negative over a positive. So what I'm going to do is I'm going to move down 3 and I'm going to move right 4 from this point, and then I'll find my next point. I connect the dots and I've graphed my line. So I'm going to go 1, 2, 3, 1, 2, 3, 4. Put my new dot, connect the lines, and I've graphed my line. So this completes the third goal for today's lesson. Again, I hope everyone's doing all right up there. Hopefully this makes sense. We'll probably have to spend a little bit more time on this. I feel like I kind of rushed the concepts here, but I will have to spend some more time on this. So I will see you guys later. Have a good rest of the day. Bye-bye.